Three objects, arriving from beyond our solar system, only three confirmed throughout human history. The first puzzled us, the second gifted us a comet to study, and the third nearly slipped by unnoticed. On July 1st, 2025, the Atlas telescope in the Rio Hurtado region of Chile detected something moving at 61 kilometers per second, 4.5 astronomical units from the sun, with a brightness of 18. Too fast to belong to us, but no one speaks of it. This object should have been discovered weeks before its appearance, but it was not. Why? Because a few weeks before the opening, the Atlas telescope was passing through dense star fields of the galactic center. Millions of stars in the background created such a dense cosmic mass that even a moving object could get lost in it. Astronomy enthusiast Sam Dean tracked it down and found additional observations of Atlas from June 5th to 25th that no one had noted. The comet was already there, moving and releasing gas, but hidden in the light veil of the stars in the central part of the galaxy. What does it mean when an interstellar visitor hides in the busiest part of our sky? What does this say about his origin? What is this object that we almost missed? If you appreciate such documentary astronomical stories, support us with your interest. Also, let us know which city you are listening from. This script is based on facts and thoroughly researched. We use data from the Solar System Dynamics database of NASA's Jet Propulsion Laboratory, updated in October 2025. The electronic bulletin MPEC 2025 N12 from the Minor Planet Center was published on July 2nd, 2025, along with peer-reviewed articles including Cordonaire's work and others published in Nature Astronomy in September 2025, and Hopkins's article in the Royal Astronomical Society Journal in July 2025. Now let's return to the information. On July 1st, Rio Hurtado, the Atlas system designated Object A11PL3Z. The initial orbital elements indicate a high eccentricity. It may fly close to Earth. The Minor Planets Center has included it in the list of confirmed near-Earth objects. For several hours, observation data is received. Zwicky Transient Facility, Lowell Telescope in Arizona, Canada, France, Hawaii Telescope on Mauna, Random Survey in Chile. Each telescope shows the same. It is not an object close to Earth. It is a hyperbolic interstellar object. By July 2nd, 2025, confirmation arrives. Eccentricity 6.141, hyperbolic excess speed 58 kilometers per second. The third interstellar object, 3 Islas. 122 observations from 31 observatories in less than 24 hours. But here's the problem. The comet was already active, bright enough for detection. The Zwicky Transient Facility captured its photographs on May 22nd. TESS, a NASA satellite for exoplanet observation, captured a comet from May 7th to June 3rd at a distance of 6.4 astronomical units. The Vera Rubin Observatory's cameras took its photographs on June 21st. The diameter of the coma was 13,040 kilometers. 11 days later, on July 2nd, the diameter of the coma increased to 18,760 kilometers. Brightness increased, and the comet became visible. But why was there a delay in its discovery? 3 and Atlas entered observation from the southern hemisphere, from the constellation Sagittarius, right along the plane of the Milky Way galaxy. When you point the telescope in this direction, you are looking at the galactic core, located 26,000 light-years away from us, where stars, dust, and nebulae are concentrated in a few degrees of the sky. Here, the star density reaches its peak, and the background noise increases. Automated telescopes, such as Atlas and Zwicky, search for moving objects by comparing images taken hours or days apart, subtracting static stars and marking everything that moves. However, when you are in the densest star field of the night sky, this subtraction becomes a complex task. The stars overlap each other, and variations in brightness due to atmospheric conditions and cosmic rays create additional noise. A faint and blurry comet slowly moves against this backdrop, easily missed or mistakenly filtered as an artifact. Amateur astronomer Sam Dan, studying archives after the announcement, found footage of Atlas taken before its discovery, from June 5th to 25th. 20 days of data, and no one noticed. The comet went unnoticed in the images as it passed through the core of the galactic center. Only when Trichonum Atlas moved far enough from this dense area and crossed into the constellation Ophiuchus on July 1st did the detection algorithms catch it clearly. The sky was clear, the stars had diminished, movement became evident, and a discovery occurred. This tells us that Tri and Atlas originated from a thick or thin disk of the Milky Way, not from the direction of the solar apex, As we expected for interstellar objects like Oumuamua or Borisov, these objects came from the north, and this one from the south, towards the galactic center. The comet has a speed u of minus 51 kilometers per second. She moves away from the galactic core at a speed of plus 18.5 kilometers per second, with high vertical motion and an inclined orbit, indicating her origin from a thick disk. If it is really from a thick disk, its estimated age is between 7.6 and 14 billion years. This is older than the solar system, older than Earth. It represents a relic of cosmic noon, the era of maximum star formation in the galaxy, which occurred 9 to 13 billion years ago. Yang V's study in September 2025 tracked its path. The comet passed within less than 1 parsec, 3 whole 3 light years from 25 known stars over the last 10 million years. But her mother star is unknown, lost in time. Details of the comet's trajectory. The perihelion of the comet Tresi Atlas will be 1 whole 36 astronomical units. This will happen on October 29th, 2025. The comet will be located between Earth and Mars, closer to Mars, on October 3rd, at a distance of 0.19 astronomical units, which corresponds to 28 million kilometers. Orbital spacecraft on Mars will be able to observe it. Mars Express from the European Space Agency and ExoMars Trace Gas Orbiter have already planned their observations. At maximum brightness, the comet will have a 9th magnitude from Mars and 12th or 13th from Earth. It is too dim for the naked eye and even for binoculars. However, 4-inch telescopes can photograph it with film resolution, but there is one problem: solar elongation. As TRES Atlas approaches perihelion, it will move behind the Sun from Earth's perspective. The solar conjunction will make it invisible from Earth from October 1 to November 9 due to its proximity to the Sun. Mars will be the focus. But this is where it gets interesting. The James Webb Space Telescope observed a comet on August 6, 2025 using the near-infrared spectrograph. The results were published on August 25th. A huge amount of carbon dioxide has been detected, with a carbon dioxide to water ratio of 8.0, one of the highest ever measured in comets. Only one other comet, C6RR2 Pan-STARRS, has similar characteristics. Why is there so much carbon dioxide? There are 2 hypotheses. Either Atlas TRES has a core rich in carbon dioxide formed near the freezing line of carbon dioxide in its star's protoplanetary disk billions of years ago, or it has a water-rich core hidden beneath an unusually thick insulating crust that retains water, allowing carbon dioxide to escape. Martin Cordiner, a NASA researcher, published this in Nature Astronomy in September 2025. The crust hypothesis: if true, the Atlas Trench hides its true composition. If we only measure what is currently released into the gas, we might miss what is inside. The comet also contains other gases: carbon monoxide at 14 kilograms per second, carbon disulfide at 0.43 kilograms per second, and water at 6.6 kilograms per second. Cyanide was detected by the Lowell Observatory on August 22nd. And confirmed by the Berry telescope on August 21st at a rate of 17.6 grams per second, while nickel in atomic vapor was 4.6 grams per second at the end of August, but there was no iron. Comets usually emit both iron and nickel in equal amounts, but Tresi Atlas breaks this rule. There is nickel, but no iron. The team of Rohan Rahat Gaonkar suggested that nickel is released as a result of the chemical decomposition of organic nickel compounds, like nickel tetracarbonyl, due to cosmic weather over billions of years, but iron is either locked away or depleted. No one knows why. Carbon chains were not detected. A large telescope searched for bicarbonate, tricarbons, amino acid radicals, but found nothing. The MDM Observatory also did not detect carbon chains in August. The ratio of second-order carbon to cyanide is one of the lowest ever recorded. 3 and Atlas have depleted their carbon chain reserves. This is an extreme phenomenon even for comets. Polarization. Observations conducted in July and August. Very Large Telescope, Northern Optical Telescope, Rosen Observatory. The results were published by Judd Gray and his colleagues. An extremely negative polarization was recorded at small phase angles. The reflected light from the comet oscillated along the plane of Sun-Comet Observer. Such a level of polarization had not been observed in any comet in the solar system or in interstellar objects like trans-Neptunian ones. This indicates that the coma consists of a mixture, including icy particles and dark organic material, tholins, and ionized compounds. However, the level of polarization is completely unique and differs from anything known. The structure of the coma was initially elongated towards the sun, rather than the opposite, forming a flag to the sunlight. The sublimation of ice on the illuminated side of the nucleus ejects dust faster. This creates an internal comet in the shape of a fan. Images from the Hubble telescope taken on July 21st show that the diameter of the core ranges from 0.32 to 5.6 kilometers, likely less than 1 kilometer. The dust ejection speed is 6 kilograms per second for fine particles and 60 kilograms per second for large ones. This resembles 2 and Borisov at a comparable distance. However, by the end of August, this flag towards the sun begins to disappear, forming an anti-solar tail. Images from the Gemini South telescope, taken on August 27th, show a tail 30 arc-seconds long, extending 56,000 kilometers and directed away from the sun. This is classic comet behavior. The pressure of solar radiation pushes small dust particles back. Rotation period. Observations from the Great Telescope of the Canary Islands conducted by Raúl de la Fuente and Marcos from July 2nd to 5th. The rotation period is 16.79 hours, confirmed by Tony Santana Ross. In August, 16.16 hours were recorded. Brightness changes decreased from 0.3 tenths to 0.2 tenths during July. The core darkens due to the thickening coma, becoming more active and releasing more dust, making it harder to observe the solid body. Also, write in the comments what surprises you the most about Triton Atlas. Now let's return to the facts. The speed is 58 kilometers per second, which corresponds to hyperbolic speed. This is the fastest confirmed interstellar object. In comparison, one Oumuamua moves at a speed of 26 kilometers per second, while 2 and Borisov travel at 32 kilometers per second. 3. Mix Atlas is almost twice as fast as Borisov. Why is that? Where does it get such speed? Gravitational maneuvers and close encounters with stars over billions of years. Wu's research identified 25 candidate stars within 1 parsec over the last 10 million years. Each interaction adjusts speed. Billions of years of interactions. Speed accumulates. Problems of discovery. A glance into the past. If Atlas had been scanned 2 weeks ago with the same sensitivity far from the galactic center, the discovery could have happened in mid-June. If the Vera Rubin Observatory had begun its scientific operations 2 weeks earlier, it could have been the first to discover the comets Tres and Atlas. Images from June 21st show a clear comet with a diameter of 13,040 kilometers, but Rubin was in the setup and scientific validation stage. She had not yet conducted a full scan. The Atlas was discovered first, but only after the comet passed through the visually cluttered space of the galactic center, which nearly caused us to miss it. Tres and Atlas moved through the densest star fields visible from Earth in late May and June. It was a missed opportunity for discovery because the background was too noisy. If this object had been smaller, less active, or dimmer, we would have completely lost it. He could pass through the inner part of the solar system unnoticed. A ghost, the first interstellar comet we never saw. How many other objects did the same? How many interstellar visitors slip away from us coming from the wrong side at the wrong time, lost in the starry haze of the galactic plane? Statistics. Matthew Hopkins, in his study published in July 2025, predicts that interstellar objects should predominantly originate from northern directions towards the solar pole, where star density is lower and they are easier to detect. However, Tres and Atlas contradict this. Their origin is the south, the direction of the galactic center. Unexpectedly, Hopkins believes this is either a rare coincidence or that objects from the south are more common than models predict. There is a shift in detection. We only find what we can see. We miss what is hidden. Tres and Atlas are well camouflaged. As for space missions, Atsuhiro and Agunima, in their research published in July, proposed launching a mission from Earth after July 1st to intercept Tres and Atlas. The minimum rate of change of speed is 24 kilometers per second, which exceeds the capabilities of existing propulsion systems. A launch before July 1st could require a rate of change of speed of 7 kilometers per second. It's possible, but no space mission was ready. The launch window to Mars. Speed change from July to September 2025. No one sent anything. Orbital spacecraft of Mars will be able to observe the comet on October 3rd from a distance of 28 million kilometers. Maven, Mars Express, ExoMars, TGO. That's all we can get. Juno on Jupiter will be able to observe in March 2026 when the Teskin-Kino Atlas passes at a distance of 0.36 astronomical units from the gas giant. However, Juno has little fuel, engine problems. Reorientation is unlikely. The spacecraft Pika will pass at a distance of 0.3 astronomical units on September 4th, 2025. The spacecraft JUICE will pass at a distance of 0.428 astronomical units on November 4th. Both devices will be able to observe. However, there are risks for the mission. Reorientation distracts from the main goals. Thermal loads. WIS will try to solve these problems. Cameras, spectrometers, particle sensors. Data will not arrive on Earth until February 26, 2026. Controversial issues. On June 20th, 2023, an article by Avalub was published in the magazine Archive, proposing the hypothesis that the object TRES Atlas may be an extraterrestrial spacecraft. He refers to its impressive size, its seemingly incredible trajectory coinciding with the plane of the ecliptic, and the absence of chemical substances detected during the initial observations. However, Chris Lintott and other astronomers immediately criticized this assumption. Life Science reports a prevailing opinion among specialists that this is a natural comet. The data analysis conducted by Lobo is deemed erroneous. Scott Manley and David Kipping point out flaws in his conclusions. Daryl Seligman, who led the first published study, notes the classic signs of cometary activity in all observations. Chemical elements were not detected in the early stages as the object was far from the sun, and its activity was low. Later observations confirmed the presence of carbon dioxide, water, and carbon monoxide. The Swift Observatory recorded water vapor and hydroxyl radicals on July 30th. In August, the VLT telescope detected cyanide and nickel. All these substances are normal volatile components for comets. There is a principle. Extraordinary claims require extraordinary evidence. The evidence presented by Lob is unconvincing. Earlier, Lob claimed that the objects Uno and Muamua and the meteorite Neos from 2014 could be of extraterrestrial origin. He has also faced widespread criticism. Lob defends his ideas, considering them an engaging mental exercise, but the data clearly points to a comet. The composition speaks of the comet. Activity speaks of the comet. Physics speaks of the comet, as well as its age and origin. If TRES Atlas is part of a thick disk, its age ranges from 7.5 to 14 billion years, with a confidence level of 68%. According to Hopkins research, the age of the solar system is 4.5 billion years. The TRES Atlas may be older than the Sun and even the Earth. It is a frozen relic of cosmic noon, when the Milky Way formed stars at maximum speed. The composition is recorded. It is rich in carbon dioxide as it formed in a protoplanetary disk with low metal content. The parent star had only 40% of the solar abundance of heavy elements, or even less. Thick disk stars are generally poor in metals. If TRES Atlas is indeed from there, it carries chemical traces from another era, a moment captured from the formation of planets 9 billion years ago, before our solar system appeared. In the future, TRES Atlas will dim. It will move away from the Sun after perihelion on October 29th. The brightness will drop below the 12th magnitude in December. It will cross the constellations of Virgo and Leo. The solar elongation will increase. The object will become visible again before dawn in November, but its brightness will be decreasing. By the year 2026, it will become too dim for most amateur telescopes. Professional observatories will continue their observations. The Hubble telescope is scheduled for ultraviolet spectroscopy in November 2025. The ratios of sulfur and oxygen, the composition of gases will be studied. The Hotwood UST Observatory will observe again in December 2025. Activity after perihelion. Potential for an eruption. Risk of fragmentation. Ivorisoft has disbanded. TRES Atlas may do the same. Thermal stress. Changes in rotation. The core may split or survive. The comet continues to lose gas, disappearing into deep space, confirmed by the star fields in the center of the galaxy. This not only highlights the complexity of its detection, but also tells the story of the comet itself. TRES Atlas arrived from the direction of the maximum stellar density of a thick disk population, possessing a high vertical speed and an inclined galactic orbit. And its age is impressive. This is not a comet that wandered from a nearby star system in the last century. This is a comet traveling through the galaxy since before Earth was formed. Billions of years in interstellar space, random encounters with stars, passes through nebulae, bombardments by cosmic rays, and slow erosion. Nevertheless, it still contains volatile substances, including carbon dioxide, carbon monoxide, and frozen water, remaining active when heated by the sun. This survival speaks of how she formed, how well the ice can be preserved in the cold of interstellar space, and how long a comet can last. Sam's search of the archives after the discovery revealed observations dated June 5th, 27 days of unnoticed data. The comet was there, its pixels recorded. Algorithms processed it, but there were interferences from the background, star confusion, and interference from the center of the galaxy. Recognition only occurred when 3 Atlas moved into a clearer sky. This 20-day pause is significant. If a dimmer object followed the same path at the same moment and crossed the center of the galaxy, we would not be able to detect it. The sensitivity threshold for tracking decreases in crowded fields. We miss some things. Most likely we are losing a lot. Observations preceding the discovery of TIS. From May 7th to June 3rd, at a distance of 6.4 astronomical units from the Sun. It is already active, already losing gas. The sublimation of carbon dioxide begins very far away. Water does not sublimate that far, but carbon dioxide does. This early activity confirms that the comet's composition is dominated by carbon dioxide. This confirms unusual chemistry. This is not a typical solar system comet that has deviated. It is something else, something from another star, another disk. Time was different. Nickel emission. Constant growth from July to August, 4.6 grams per second by the end of August. As the comet heats up, more nickel vapor is released, but there is no increase in iron content. This discrepancy is a mystery. Standard models claim that nickel and iron sublimate from dust grains together. Thermodynamic decomposition of minerals, but the 3 Atlas do not follow standard models. It releases nickel without iron. Rahat Gaon-Kara's team suggests the presence of organic carrier molecules. Organic substances rich in nickel decompose under the sun's heat and ultraviolet rays, releasing nickel atoms. But where did these organics come from? How did nickel get into organic structures in the protoplanetary disk? No one knows. No laboratory experiment confirmed this. No theory predicted it. Nevertheless, it is observed in the spectrum. Emission lines are growing every day. Carbon chains are depleted. There is no disinane, no trincane. The lowest ratios of carbon to sulfur have been recorded. Standard comets have carbon chains. They form from organic material in the core, which decomposes under heat. 3 Ilises contain organic substances. We know this because they contain tolins, reddish compounds that include nickel, but carbon chains do not form. Why? A possible explanation. The organic matter in the 3 Illis is different. It is more complex and stable, not decomposing in the same way. Alternatively, the chemistry of the parent star's disk may have been different. A lower ratio of carbon to oxygen, various pathways for molecular formation, or cosmic erosion over billions of years changed the surface composition, destroying reactive carbon and leaving only stable organic compounds. Data from the Varick Observatory. Rubin, growth of the coma. On June 21st, 13,040 kilometers. On July 2nd, 18,760 kilometers. The growth rate is about 500 kilometers a day. Linear expansion as gas and dust are ejected from the core. Images from Rubin also limit the core size, likely less than 5.5 kilometers, possibly under 1 kilometer, according to dust ejection speeds. Hubble further clarifies this. Images from July 21st show a range from 0.32 to 5.5 kilometers. The best estimate is less than 1 kilometer. It looks like 2 Iores, a small core, with high activity for its size. Degassing caused by carbon dioxide creates a large coma around the core's diameter. The encounter with Mars on October 3rd, 0.19 astronomical units. Mars will see Tri and Atlas brighter than Earth ever was. Magnitude 11 from the Martian surface. Martian orbiters are closer. The best resolution. A multitude of tools. Mars Express, high-resolution stereo camera, trace gas orbiter, spectrometers. This is the best chance for observation for any spacecraft. Mars is in the right place at the right time. Earth is not. The solar conjunction blocks visibility from Earth during perihelion. Mars has clear lines of sight. If Martian orbiters capture detailed spectra, we will obtain data on composition during peak activity. We will achieve spatial resolution of the coma structure. We will see changes in brightness in real time. This data will be uploaded over several weeks, but it will come. Ultraviolet spectroscopy in November from Hubble. The ratio of sulfur to oxygen. a key measure. It speaks of the chemistry of the parent star's disk. High sulfur content indicates a reducing environment, low oxygen activity. Low sulfur content indicates an oxidizing environment, a water-rich disk. This ratio changes depending on the type of star, metallicity, and disk temperature. The ratio of sulfur to oxygen in Comet Atlas will determine what type of system it belongs to. In combination with the ratio of carbon dioxide to water, the amount of carbon monoxide, and the presence of nickel, we can create a picture not of the parent star itself, which we will never know, but of the type of star and the type of disk. The conditions for formation span 9 billion years. Observations by the James Webb Space Telescope in December, after perihelion, will help identify changes. Did the desorption rates change? How did the ratio of carbon dioxide to water change as the comet approached the sun and heated various layers? New volatile substances have appeared, confirming fragmentation. Has the core survived, or has thermal stress damaged it? Perhaps it will crack, as happened with Borisov. Or Atlas might also break apart. If this happens, we will see fresh internal material, the composition of which has not been altered by cosmic erosion and has been preserved since the protoplanetary disk. This will be a true scientific discovery, but perhaps it will not break apart. Perhaps it is too small for significant thermal stress, or its structure is strong enough to endure. We will find out in December. What do the star fields of the galactic center hide? In late May and June of 2025, Atlas crossed the visible star field, the densest from Earth's perspective. At the moment, it began to shine brightly and became easily distinguishable. Many studies were supposed to detect it, but the background light of the stars absorbed it. Automatic detection algorithms depend on the clarity of their images. They compare two images, subtract static sources, and mark moving objects. But when there are millions of static sources packed tightly in a frame, subtraction does not yield a clean result. Remnants and noise peaks appear. False triggers fill the system. Algorithms adjust thresholds to compensate. Real signals are filtered out below the threshold. The Atlas was below this threshold. It was real. It was there, but it was filtered out. The data recovery from the 5th to the 25th of June confirms this. A manual inspection of these frames shows a blurry comet moving exactly where the orbital elements predict, but the automated system did not detect it. Human eyes found him only after they knew where to look. This is the lesson. Automated research works well in sparse fields, but struggles in crowded ones. Interstellar objects coming from the direction of the galactic center face detection issues. We might completely miss them. Atlas was lucky. It quickly brightened, and by early July moved far enough from the densest part of the plane, crossed clearer skies, and was spotted. If it had a size of 19 instead of 18, if it had appeared 2 months later, when it would be deeper in the light, if its orbit had kept it in the plane longer, it would not have been discovered. It would have disappeared. The origin of the thick disk. Consequences. The thick disk is ancient and poor in metals. Stars formed between 9 and 13 billion years ago. If Trey Atlas is from a thick disk, he is a relic. He is older than the Sun by 5 to 9 billion years. It formed when the universe was 4 to 8 billion years old, when the Milky Way looked different, when the rate of star formation was higher, and when protoplanetary disks had different chemistry, lower metallicity, and fewer heavy elements. This environment produced comets with excellent composition. They were rich in carbon dioxide and poor in carbon chains, organic substances containing nickel with unusual polarization. Thus, planetary formation occurred in the early galaxy. Trey Atlas is a messenger, not from another star, but from another era. The components of speed tell a story. -51, moving away from the galactic center, plus 18 and 5, significant perpendicular motion. The orbital tilt relative to the galactic plane is expressed. This is not a comet of a thin disk that gently rotates in the plane. It is a comet of a thick disk with a tilted orbit, periodically crossing the plane, spending time both above and below. This vertical movement signifies antiquity, dynamic heating, forming in another population. Guo's research discovered 25 stars within 1 parsec over 10 million years. But 10 million years is nothing. The comet is billions of years old. It has encountered thousands of stars, hundreds of nebulae, performing gravitational maneuvers at every close distance, changing speeds. The orbit is evolving. At this stage, its trajectory is tangled. There is no way to trace it back to the source star. This star may have not existed for 9 billion years. This is a long time. Stars die. The progenitor star could have been a white dwarf. It could be a neutron star, It could explode like a supernova, and we will never know what this reveals about Trey Atlas. This is not just an interstellar comet, it's a time capsule. The chemistry of the cosmic noon of the galaxy. Ice preserved for 9 billion years in the cold of interstellar space. Organic matter, irradiated by cosmic rays, altered by cosmic erosion, yet still intact. A small but active core. Volatile substances sublimate even at a distance of 6 astronomical units. Rich in carbon dioxide, unlike any other. Emits nickel, as few do. Depleted by carbon chains like almost no one. Extreme polarization. Every measurement violates norms. Each observation adds strangeness. The star fields concealed him because he came from the direction of the galactic center. The direction to the center of the galaxy is the area from which thick disk objects emerge in our field of view. The thick disk is the habitat of old comets. These comets carry the chemistry of the early galaxy. Comet 3 and Atlas brought this chemistry into the solar system. We barely noticed it. Samden discovered hidden data. Zwicky, Atlas, Rubin, all of them had photograms. All of this was missed in real time. Only a retrospective analysis restored the complete chronology of events. This chronology shows early activity, demonstrates the rapid growth of the comet. It indicates that the comet was ready to be discovered weeks before it was actually found. But the stars in the background said, no. Future detection. If another comet try and Atlas appears, on the same trajectory, at the same moment, and in the same direction, we will detect it. The Rubin Observatory is already operational, full research mode, scanning every 3 nights, deeper than Atlas, more sensitive. Perhaps she handles crowded fields better thanks to advanced algorithms. But if the object is less bright, less active, smaller in size, it may not work. Star fields in the center of the galaxy remain the most difficult area to explore. High background, high confusion, high probability of errors. We need new strategies. Machine learning specifically trained to work with crowded fields, manual analysis of border detections, coordination between observations, real-time comparison between Atlas, Zwicky, Rubin, Apan, and the stars. If all 4 capture something boundary-related in the same location, mark it. It doesn't matter if individual observations filter it out. The generalized signal takes precedence. Comet 3 and Atlas will disappear from history in December 2025. The last observation using the James Webb Telescope. The lost tracking with Hubble. Brightness 14, 15, 16. Professional telescopes will lose sight of it in mid-2026. The orbital elements are refined, the composition cataloged, the data archived, but the comet continues to move at 58 kilometers per second relative to the Sun, distancing from perihelion, away from the solar system, away from Mars, Earth, and all the planets. By the year 2030, it will be beyond Neptune. By 2040, in the Kuiper Belt. But it will not become part of it. It is still in motion, unbound by gravity. By 2050, it will leave the solar system, as defined by the heliopause. By the year 2000, it will be a light year away from us, once again in the cold, dark, inactive interstellar space, with a frozen core, without descalification, without a coma, without a tail, just a small dark and icy rock drifting through the galaxy, waiting for the next star, the next close approach, the next heating. After billions of years, it may enter another system, shine again, begin to desgasify, and some other form of life, if they have telescopes, if they have observations, if they look in the right part of the sky, will be able to see it. They may call her an interstellar visitor. They may wonder where she came from, but we know where she came from. A thick disk, an ancient galaxy, cosmic midday. We know that this object nearly eluded us, hiding for weeks in the star fields of the galactic center. We know that Samden discovered the lost data. We know that the object is rich in carbon dioxide, is a source of nickel, and is depleted by chains of carbon with extreme polarization. We know that Mars's orbital spacecraft will be able to see it better. We know that this is the oldest comet we have ever studied. We know he will not return. Final data, perihelion, October the 29th, 2025, 1.36 astronomical units. Eccentricity, 6.14. Hyperbolic speed, exceeding 58 kilometers per second. The closest approach to Earth is December 19th, at 1.8 astronomical units. The core diameter is likely less than 1 kilometer. Carbon dioxide emission is 129 kilograms per second. Cyanide, 17.6 grams per second. Nickel, 4.6 grams per second. Iron is absent. Rotation period, 16.2 hours. Age from 7.5 to 14 billion years. Origin, a thick disk. The parent star is unknown. Discovery, July 1st, 2025. Observations before the discovery, until May 7th. Gap in observations from June 5th to June 25th, due to interference from the star field of the Galactic Center. 122 observations from 31 observatories within 24 hours after the announcement. On August 27, 2025, the Gemini South Observatory photographed TR and Atlas moving against the backdrop of distant galaxies with a visible tail stretching 56,000 kilometers, directed away from the Sun as expected. And in these images, dull spots of distant galaxies, located billions of light years away, are positioned behind a comet that is 9 billion years old, and the contrast is simply shocking. The galaxies are ancient. The comet is old, but it is here, now, in our solar system, for the first and last time. And in 100 years, all the astronomers living today will be dead, and Atlas will disappear, leaving only archival data and published articles as proof of its existence. In this moment, when a piece of ice 9 billion years old from a dead star disk flew by, almost escaping detection, it was noticed and showed us the chemistry of cosmic noon. We left Tress and Atlas on a collision course with fate, not with a planet, but with the unshielded brilliance of the Sun. By the end of September 2025, ground-based telescopes began losing the battle. The comet was sinking into the evening twilight, the angle with the Sun decreasing each day. We knew she would disappear behind our star for weeks, hiding at the most critical moments. But we had a reference point, a witness robot at the right time and place. Mars.